Hi, this is Henry, and today I'll be presenting nuclear energy. And here's a table of contents. So first, it will be the introduction to nuclear energy, and then how it is produced, and the energy transformation, chemical process, and whether it is renewable or not, and then its advantage and also disadvantages, and where it's used globally and in Canada. So nuclear energy is released from the nucleus of atoms through a process called nuclear fission. And it is mainly used to generate electricity in nuclear power plants. And the most common fuel used is called uranium-235. And it is a radioactive isotope that is highly efficient for this purpose. And how it is produced. So nuclear energy is produced in reactors. So inside these reactions, uranium atoms are bombarded with neutrons, which causes them to split. And it is a process known as fission. So this fission releases a huge amount of heat, and which turns water into steam. And then the steam then spins the turbine connected to generators. And that's how electricity is produced. So as you can see, um, on the graph below, it clearly explains how the process of nuclear energy generation. So here's the energy transformation. So it starts as a nuclear energy inside uranium, and then the fission, just as we mentioned, it converts that to thermal energy, and then the steam's movement becomes mechanical energy, and finally, because the steam pushes the turbines, and then the spinning turbines produce electrical energy through generators. And this chain of energy transformation is highly efficient compared to fossil fuel and many other kind of energies. And at the bottom, it is the chain of energy transformation. So here's the chemical reaction involved. So it is the U-235, and then plus N is neutron, and then it will make it into fission products, and then 2 to 3 neutrons and plus energy. I'm sorry, I think I over duplicated. And each fission reaction releases millions of times more energy than burning the same amount of fossil fuel. So the key technologies involved are reactors, and which are CANDU, and it is used in Canada, and also control rods, which can be used to manage the reaction, and then the cooling systems, which is used to prevent overheating, and last it will be the containment structures. It is just for safety. And then whether it is renewable or not. Um, but um, it is actually not non-renewable because uranium is a finite resource. But however, it is more sustainable than fossil fuels, as uranium lasts much longer. And there's ongoing research into advanced reactors like breeder reactors or um, the use of thorium to potentially make nuclear energy more sustainable in the future. And here I will compare the pros and cons. So the advantages of nuclear energy are it produces a huge amount of electricity, and then there's no carbon emissions during operation. And LS is reliable and pretty much a consistent supply. And then on the other hand, the disadvantages are it produces radioactive waste, just like the one in Japan. Unfortunately, um, it has lasted for hundreds of years, right? And the high initial cost to build plants, and then there's a risk of nuclear accidents, though rare, just as we mentioned, the one in Japan, but I forgot its name. And at last, it will be the applications. So nuclear energy is used in over 30 countries, and the top users include the US, France, China, and Russia. And it provides around 10% of the global electricity, which is much lower than the fossil fuels, which are about 80%. And then about in Canada, it plays a major role, especially in Ontario, where it supplies over 50% of province's electricity. And Canada uses CNDU reactors, which have the advantage of using natural uranium, which is the photo on the bottom right corner. And here's a comparison, which is the nuclear energy usage of global versus Canada, which Canada has a pretty much like 4% lead than the global. So this will be my references. And now I would like to conclude my presentation. So although the nuclear energy is powerful and efficient and low emission, but there's some challenges for its convenience, which are the potential risk of nuclear incidents um, or some waste waste management problems. So we we may need to transition into to a much more cleaner and more efficient energy systems. So we'll find out that in the future, I guess. And that's the end of my presentation. Thank you.